Okay, so here's a practice test that goes through some redox questions that I think are a good review of lots of theory. So this first one is asking about strong oxidizing agents and which statement would be false. So just going over, if you are a strong if you're a strong oxidizing agent, you are undergoing reduction, right? So I'm going to write out RIG here, meaning reduction involves a gain of electrons. So let's go through that. If it's the first statement, a strong tendency to be reduced, that's true. Oxidizing agents undergo reduction. B, they have relatively high reduction potentials. That is also true because you're undergoing reduction. C, you have a tendency to gain electrons. That is also true. So we can be pretty confident that since the other three were true, that our answer here would be D. But then we can use an example. If you had something like iodine and it gained electrons, you would end up with the ion and electrons. So you'd balance this out and we can go from there. You would need some 2's in here. But when we have this and we see that gain of electrons, if you were to assign oxidation numbers, iodine by itself would be 0. And when it is its ion, it would be -1. So going from 0 to -1, that would be a decrease, not an increase in numbers. So that's why that last one wasn't true. Question number 2, I feel like is a common question by giving you a series of reactions and asking which one is not a redox. So I'm just going to use this first as an example and then go through that answer. So with A, if you assigned oxidation numbers, we'd have 0 for zinc, 0 for sulfur by itself. And then within this compound, zinc would be +2 and sulfur would be -2. The fact that you have one value getting greater, more positive, and one being more negative means you have an OA and an RA. As long as something's undergoing reduction and something else within is undergoing oxidation, you're a redox reaction. So this one is. Now, I know here that the answer is D, so let me just show you why. So if you started with these are reactants. If you started with the reactants and you assigned oxidation numbers, so we know oxygen is always -2, potassium is +1, and our whole thing has to add up to 0. So starting with oxygen, there's 4 of them, all of them -2, would give you -8. Potassium, there's 3 of them with +1. That would mean phosphorus would have to be +5. So we can keep going here with assigning oxidation numbers, just doing what we know. So the next one, -2, +1. Nitrogen would have to be +3, so our compound could be neutral. On the product side, I just missed my 3. We'd have -2, +1, and phosphorus one more time would work out to +5. And then that last one, 3KNO3, oxygen's always -2, potassium's +1, and nitrogen would be +5. So when we go to see what your OA and RA would be, we would notice that nothing changed. Potassium is +1 on both sides, phosphorus is +5 on both sides, and we can keep going and see there's no change in oxidation number. So even though we have a reaction, it's not a redox reaction because there's no OA, there's no RA, where the rest of them would be like A, and you would see that change in oxidation number. Looking at this next question, you have some information about zinc, and then it tells you if in the process of being oxidized, that what would happen to the zinc. So if we read this over and the zinc was being oxidized, if you're undergoing oxidation, remember oxidation involves loss, zinc would turn into zinc 2 positive, and you would have 2 electrons free. So going through this, just right away, we should know that C and D are going to be false because when we're being oxidized or reduced, you're exchanging electrons. It has nothing to do with protons. So then looking at either A or B, when it says A gained electrons to produce more zinc, well, we know that's not true because if you're being oxidized, you will be losing electrons. So lost electrons and became zinc 2 positive. That is definitely our answer. Okay. So so moving on from this one, we now are getting a little bit more complicated. So here we have a reaction that is unbalanced, and we're told it's a redox reaction, and we're also told that it is an acidified reaction. So I know I can balance this using acidic conditions. So to do that, I'm just going to take a look at my reaction and see what's related. So for instance, these two would be related, and the one with chromium turning in chromium 3 positive would be related. So I'm going to start with writing that out. So Cr2O7 with a charge of -2 turning into chromium 3 positive. If I balance this with acidic conditions, I would have to add in 7 water molecules to balance out hydrogen. That now also, actually before I do that, I would have to balance out my chromium, so putting a 2 here. Now I could add in some hydrogens. So on the other side, I'm going to add in 14 hydrogen molecules. And the last thing I need to do is balance my charges. So on the left-hand side, I have a net charge of +12. And on the right-hand side, I have a net charge of +6. So I'm going to add 6 electrons to the reactant side so that both sides have a net charge of +6. Now my second half reaction was with the CH3OH, and that was turning into CH2O. So I'm just doing the same thing. I need to balance out. Carbon's already balanced. Oxygen's already balanced. So I'm just going to add in 2 more hydrogens on the right-hand side. And I'm also going to add in 2 electrons to balance my charges. Now that I have this, I would be multiplying this second reaction by 3 so I can exchange 6 electrons. When I do that, I could take a look and see when I do that and then add my reactions together, that it's going to be the one with 8 hydrogens. It's going to be C. So I could write this all out, and what would happen is once you multiply the hydrogen by 3, there would be 6 of them. And because that's occurring on both sides, 6 of the hydrogens on the product side would cancel out with 6 of the hydrogens on the reactant side, and then everything else ends up being balanced out, and nothing else would cancel. And that's why our answer is C. The second last one, when you have this question about the acidic medium and the permanganate reacting with SN2 positive, asking what is the balanced oxidation half reaction for the given reaction. I'm just taking a look at what's related, and if it's undergoing oxidation, oxidation involves loss. So we would have one half reaction involving the tin, and then your other half reaction would be the permanganate with the hydrogen, and then we would balance it out. So because it's oxidation and it's involving loss, and your tin 2 positive is losing electrons and turning into tin 4 positive, that would mean the answer would be, which is our first one, is A. So this one's kind of nice to us because we don't have to work with the more complicated reaction. We just have to realize how we oxidize that tin 2 ion. And this very last one, what's that? Here we go. Oh, this last one did not turn out. So maybe we'll just stop it there for this one. And as always, I hope you found this helpful. And if you did and made it to this point, please subscribe. And if there's any other video I can ever do for you, just let me know in a comment. Thank you for watching.